capacitor testing. So here we got two motors, two different capacitors. Don't know all these. One's got a resistor to bleed off any excess voltage. The other one does not. So testing. There's generally a few ways. I've heard of the spark method. Don't advise that. The next method is you can check resistance. So the first thing to do with these is short them. You don't want to test this thing if there's voltage in there. So you just something insulated on your end, and then a nice metal contact between the two ends to short it. Okay. So if there's any juice in there, it'll dissipate. All right. There we go. So no voltage, nothing, no capacitance in there. Now, the first thing you can do, you can do a ohm test. That's simply placing your two leads onto the two terminals, and you should see a value going up. This value is going down. Ah, there we go, now we're going up. So that should tell me it's okay. Now if it stayed at a number, then it's no good. Other one, there we go, and we are going down, which means this is not taking a charge, which means this one is bad. The next method is the capacitor test. If you have this on your meter, see this little guy right here, the yellow guy. Now we're reading microfarads, which is what these are measured in. So first, look at the number on here. This one is rated 180 to 156 microfarads. That's a weird number. Usually it goes the other way around. It's lower to higher, but whatever. Oh, I care. So here we are. Once again, two terminals. We're reading 134 microfarads. So within 10 to 20% of the allowable value, it's okay. So if that is a 156, 10% would be 15, 20% would be 30. What did we say we were? So we were reading 134 microfarads. This says 180 to 156. So 10% would be 15.6. So 134 plus 15, blah, blah, blah. So that would not meet that. 20%, however, would be 30. And that would be within. But that's really sketchy. I'm going to say this capacitor is no good. Here we go, capacitor number 2. Capacitor number 2 is rated 250 to 300 microfarads. We are 247, just outside the range, but well within the 10 to 20% allowable. So that would mean this was good. Very low, but good. However, this is the one that had a low number, or the number going down. This is the number going down. So once again, both capacitors are bad. What we're looking for is a resistance value that continually goes all the way up to infinity. Doesn't matter how long it takes. So what that means is it's taking a small charge and holding it. Or we're looking for a capacitance value, which is listed here, within, give or take, 10% of the thing. So, also this is important. This is 110 volts AC. Your capacitor should be rated for the same voltage value of your motor or greater. So if we're running 220, that's not going to work. 60 hertz, what you should see on every capacitor you're dealing with in America, because we use 60 hertz. That's the frequency we use here. This one says 50 to 60, so it can be used anywhere, made in France, so it's good for Europe or here. Also 110, so it wouldn't work here. So, two bad capacitors. Alright, if you've got anything you want to say, or any questions, or if you think I got something wrong, hit me up in the comments.
In the case you just want to see what the inside one of these things looks like, I cut one open for you. Alright, it's pretty old, but that's it. Let's just unravel that. There you go, and that's the inside.